Hello everyone. Today we are going to derive a formula for the horizontal thrust of a two-hinged parabolic arch. Let us read the question one time. Derive the horizontal thrust formula for a two-hinged parabolic arch when it carries uniformly distributed load for the left half span. Also, find the expression for the maximum and minimum bending moments. As given in the question, this arch is carrying UDL on the left half span. In this question, we have to make the expression for the horizontal thrust. Also, we have to make the expression for the maximum and minimum bending moments. In this arch, L is the length or span of the arch. Small h is the rise of the arch. Capital H is the horizontal thrust. VA and VB are the vertical reactions. Now let us find the vertical reactions. First we are going to find VB. For that I am going to take moment about A. In this case we are moving towards left hand side. Clockwise will be negative, anti-clockwise will be positive. The vertical reaction VB is acting towards the point A in the anti-clockwise direction. So it will be positive. And the distance is L, so VB into L. The UDL is acting towards the point A in the clockwise direction, so it will be negative. For the UDL, we have to multiply the distance and the distance by 2. The distance is L by 2. Distance by 2 is L by 2 into 1 by 2. L by 2 into 1 by 2, we will get L by 4. L into L, we will get L square. 2 into 4, it will be 8. We can take this on the right side, it will become positive. We can cut this L and square. Finally, for VB, we are getting WL by 8. We have found VB. Now let us find VA. We can easily find VA by taking the total load. In this arch, we are having UDL. This UDL is acting for the distance L by 2. To find the total load, we have to multiply the UDL with the distance. When we do that, we are getting WL by 2. Now we can apply the rule. The summation of upward forces is equal to summation of downward forces. The upward forces are VA and VB. So VA plus VB is equal to the downward force WL by 2. We have already calculated VB. We can apply that. Then take LCM. For taking LCM, we can multiply the numerator and denominator by 4. 4 WL minus WL, we will get 3 WL. Finally, we are getting VA is equal to 3 WL by 8. We know the formula for the horizontal thrust. H is equal to integration of m0 y dx divided by integration of y square dx. In this formula, first let us find the numerator integration of m0 y dx. To find this, we have to make sections in this arch. In this arch, we are having two different parts. On the first half, we are having UDL. On the second half, there is no load. So, we have to make two sections, one on the first half and one in the second half. So, we have to split the formula into two parts for the first section and for the second section. You can see that I have made two sections for the first half and for the second half. Both of the sections can be made at the distance of x. Also, I have split the formula into two integrations. For the first integration, the limits will be 0 to L by 2. For the second integration also, the limits will be 0 to L by 2. Here we have to be careful. When we calculate m01, we must calculate from the point A. When we calculate the moment m02, we must calculate from the point B. In this formula, first I am going to calculate integration of m01 y1 dx. Now let us calculate m01. We are going to calculate m01 from the point A. In this case, we are moving towards right hand side. Clockwise will be positive, anti-clockwise will be negative. We know that m0 is the moment without considering the horizontal thrust. So when we take moment, we should not include the horizontal thrust. Up to the section, we are having two vertical loads, the vertical reaction VA and the UDL. The vertical reaction VA is acting towards the section in the clockwise direction, so it will be positive and the distance is x. So 3WL by 8 into x. The UDL is acting towards the section in the anti-clockwise direction, so it is negative. When the UDL comes, we have to multiply with the distance and the distance by 2. Here the distance is x, so x into x by 2. X into x, we will get x square. We can take from here w by 2 outside. When we take w by 2 outside, we will get this. Finally, we have made m01. We know the formula for y, 4hx into L minus x by L square. Let us apply the values of m01 and y in the formula. We can cut this 2 and 4. Here it will be 2. Then we can take the constants outside. W, L square, H, these two are the constants. We can take them outside. Then let us multiply these two values. First, let's multiply 3lx by 4 with the L minus x. When we do that, we will get these. Then let's multiply minus x square with the L minus x. When we do that, we will get these. Then let us multiply x with this value. When we do that, we are getting this. Then we can use the calculator. Minus 3 by 4 minus 1. We will get minus 7 by 4. Then we can go for integration. We know the formula for the integration. Integration of x power n dx is equal to x power n plus 1 by n plus 1. When we integrate x square, we will get x power 3 by 3. When we integrate x power 3, we will get x power 4 by 4. When we integrate x power 4, we will get x power 5 by 5. Now let us apply the limits. No need to apply the lower limit because the whole term will become 0. Only apply the upper limit. When we apply L by 2 instead of x, we will get L power 3 by 8. When we apply L by 2 instead of x, we will get L power 4 by 16. When we apply L by 2 instead of x, we will get L power 5 by 32. Now we can use the calculator. 3 by 96 minus 7 by 256 plus 1 by 160. We will get 13 by 1280. Now we can cut this 2 and 1280. We will get 640. Finally, we have calculated integration of m01 y1 dx, which is equal to 13 whl power 3 by 640. In this formula, we have made the first integration. Now let us make the second integration. Now let us calculate m02. M02 should be calculated about the second section. Up to the second section, we are having only one vertical load. We should not consider the horizontal thrust for calculating m0. So we are having only one load. We are going to calculate m0 from the point B. In this case, we are moving towards left hand side. Clockwise will be negative, anti-clockwise will be positive. The vertical reaction WL by 8 is acting towards the section in the anticlockwise direction, so it will be positive and the distance is x, so WL by 8 into x. Finally we will get WLX by 8. We know the formula for y, 4hx into L minus x by L square. In the formula, let us apply the values of m02 and y. We can cut this L and square. Also 4 2s are 8. WH by 2L are the constants. We can take them outside. Then let us multiply these two values. When we multiply, we are getting this. Then we go for integration. We know the formula for the integration. Integration of x power n dx is equal to x power n plus 1 by n plus 1. When we integrate x square, we will get x power 3 by 3. When we integrate x cube, we will get x power 4 by 4. Now let's apply the limits. No need to apply the lower limit. When we apply the lower limit, the whole term will become 0. So only apply the upper limit L by 2. When we apply L by 2 instead of x, we are getting L power 3 by 8. Also, when we apply L by 2 for x, we will get L power 4 by 16. Now we can use the calculator. 1 by 24 minus 1 by 64, we will get 5 by 192. 2 into 192, we will get 384. Finally, we have found the integration of 0 to L by 2 m02 y2 dx, which is equal to 5 wh L power 3 by 384. Now let us apply the values of integration of m01 y1 and integration of m02 y2 in the integration of m0y formula. We can take wh L power 3 outside, then we can use the calculator and add the values. After adding the values, we are getting wh L power 3 by 30. In the horizontal thrust formula, we have calculated the numerator. Now let us calculate the denominator. To calculate integration of y square dx, only one section is enough because the value of y will be changing constantly. So only one section is enough. We can make the section randomly anywhere. I have made the section randomly here. The limits for the integration will be 0 to L. We know the formula for y, 4hx into L minus x by L square. We can apply that here. Then we can take the constants outside. 4h and L square are the constants. But before taking the constants outside, we have to square them. When we square 4h, we will get 16h square. When we square L square, we will get L power 4. For L minus x the whole square, we can apply a minus b the whole square formula. Then let us multiply x square with this value. After multiplying, we are getting this. Then we can go for integration. When we integrate x square, we are getting x power 3 by 3. When we integrate x cube, we are getting x power 4 by 4. When we integrate x power 4, we are getting x power 5 by 5. Now let us apply the limits. No need to apply the lower limit because it is 0. Only apply the upper limit L. When we apply L instead of x, finally we are getting this. Now we can use the calculator. 1 by 3 minus 1 by 2 plus 1 by 5, we will get 1 by 30. We can eliminate this L power 4. Here it will be L. 16 by 30, we will get 8 by 15. Finally, we have found integration of y square dx, which is equal to 8 LH square by 15. In the horizontal thrust formula, We have found the numerator and the denominator. Let us apply both of them. We can take the denominator inversely and then multiply. Then we can make some simplifications. We can cut this 15 and 30. Here it will be 2. Also we can cut this L and cube. Here it will be square. We can cut this H and square. Finally, we have made the formula for the horizontal thrust, which is equal to WL square by 16H. Now let us find the maximum positive bending moment. This arch is loaded on the left side. There is no load on the right side. So the maximum positive bending moment occurs at the left half of the arch. Let us make one section randomly at a distance of x on the left half. This section is made at a distance of x from the point A. In this section, let us calculate the moment. We are going to calculate the moment from the point A. In this case, we are moving towards right hand side. Clockwise will be positive and clockwise will be negative. The vertical reaction is acting towards the section in the clockwise direction, so it will be positive and the distance is x. The horizontal thrust is acting in the anti-clockwise direction, so it will be negative. For the horizontal thrust, the perpendicular distance is y. We already know the formula for y. We can apply that. The UDL is acting in the anti-clockwise direction, so it will be negative. When the UDL comes, we have to multiply with the distance and the distance by 2. Here, the distance is x, so x into x by 2. Then we can make some simplifications. We can cut this L square and L square. Also we can cut this H and this H. We can cut this 4 and 16. Here it will be 4. X into x, we will get x square. Then we have to multiply w by 4x with L minus x. When we do that, we are getting this. 3 by 8 minus 1 by 4, we will get 1 by 8. 1 by 4 minus 1 by 2, we will get minus 1 by 4. For the maximum bending moment, there is one condition. When we differentiate mx with respect to x, it will be 0. Let us differentiate. When we differentiate x, it will be 1. So we will get WL by 8. When we differentiate x square, it will be 2x. So we are getting 2xw by 4. Then we can take 2xw by 4 on the right side, so it will be positive. Then we can cut this 2 and 4. Here it will be 2. Now let us take w by 2 on the right side. It will come inversely. We can cut w and w. Also we can cut this 2 and 8. Here it will be 4. Finally we are getting x is equal to L by 4. Let us apply x is equal to L by 4 in this equation. After applying, we are getting this. 4 8s are 32. 4 square, we will get 16. 16 into 4, we will get 64. Then we can use calculator. 1 by 32 minus 1 by 64, we will get 1 by 64. So the maximum positive bending moment is equal to WL square by 64. And it occurs at x is equal to L by 4 from the left. Now let us find the maximum negative bending moment. It occurs on the right half of the arch because on the right side there is no load. Let us make a section randomly at a distance of x from the point B. In this section we have to calculate the moment. We are going to calculate the moment from the point B. In this case, we are moving towards left hand side. Clockwise will be negative, anti-clockwise will be positive. The vertical reaction is acting towards the section in the anti-clockwise direction, so it will be positive, and the distance is x, so WL by 8 into x. The horizontal thrust is acting in the clockwise direction, so it will be negative. For the distance, we have to take the height, that is y. We know the formula for y, we can apply that. After making the simplifications, we are getting this. We know that for maximum bending moment, dmx by dx is equal to 0. We have to differentiate this equation with respect to x. When we differentiate x, it will be 1. So we will get minus wl by 8. When we differentiate x square, we will get 2x. We can take minus wl by 8 on the right side, so it will become positive. Finally, we are getting x is equal to L by 4. We can apply the value of x in this equation. After applying, we are getting the maximum negative moment, which is equal to minus WL square by 64. It occurs at x is equal to L by 4 from the right side. Now we are going to end this session. Thank you for watching this video.